Good morning and welcome to last day of database. No, not really. We have another week. So today we talk about data modeling. This is one of those things where practice is going to make perfect for sure, but also it's going to feel a little abstract. So there is no JavaScript code to write. There is no algorithms. There's nothing. There's more a set of kind of guidelines for you to follow. Well, and the goal of today is I have requirements, something that I need to implement. So probably a good example of that. Let's look at the challenge for today. That will help. Oh, there's nothing here. Only get ignored and read me. Okay, let's read through it. Not all of it. So the assignment is you're going to design the data model. What I mean by that is what is the structure, the schema for your database? What tables do you need? How are they related to each other? And what are the columns or properties that you have on those tables, right? Then you're gonna use connect migrations and seeding. We didn't show seeding, but just do the migrations where RTLs are gonna let you get away with no seeding to build a SQLite 3 database. All right. So here's the requirements, and this is what you're gonna hear from clients. Some accountant comes to you and say, "I want you to build a system for me," and they're not gonna talk about tables and foreign keys and primary keys and none of that, unless they know a little bit about programming. But normally they're going to talk about accounting. And if you have a doctor and they want a system for their office, for their practice, they know about medicine. They don't know about code. Okay. So the requirements are, and this is stated by the client, they say, "Hey, I want to have a way to manage my recipes. I want to have a way to manage ingredients. A recipe could have more than one ingredient, hopefully, right? Otherwise it would be like just salt, not good. And the same ingredient can be used in multiple recipes. Again, salt can be part of more than one recipe. And then when saving the ingredients for a recipe, I want to know the quantity that I need. Is it 2 cups? Is it 2 spoons? Okay. And I want that to be a floating number. And they're probably going to say, they're not going to say floating number, but they're going to tell you something like, I want to record fractions like 1.5 cup, right? And a way to save step-by-step instructions for preparing the recipe. This could be complex, or this could be super simple. Go simple first, and if you have time, then change it into a little more complex. By simple, I mean you could have a big text field where they could just type out all the instructions. A cooler version of that is you have a set of steps that you can even reorganize. Say first this, right? Separate steps, where each step is its own row somewhere. So before writing any code, write out all the desired tables in the data model and determine the relationships between the tables. That's a hint. I'm going to show you a workflow that you can use for that. So for the migrations, just what you learn about migrations and seeding, I could show you how to do seeds if you want today, but Reese can also hold a little out-of-band group and show you how to do seeding because it's pretty simple. And then, of course, you have some data access. And we're only asking for 3 methods here. So follow the instructions first. Make a simple model. I mean, we have time, go and do more. There is also a training kit, of course. There's a video for that, for the seeding. And then you have stretch problems, okay? Questions about the exercise first. So what I want you to notice here is that most requirements are going to be written, good requirements that is, they're going to be written in the language of the system, of the language of the domain. So doctors will talk doctor stuff and accountant stuff. And then your job is to translate that into techie stuff, into what can I, depending on your stack. In this case, is for the data storage, it's going to be relational database. So you translate that into a relational database schema. Okay. So if you have questions, please, on Slack, as always. I will make it so that you can unmute. Thank you, Visual Studio Code. So that you can unmute. And we can go with, I normally take this with talking about the school, a model for the school, but we could do any other model that you wanna see. So if you have one, let me make sure that you can unmute, speak up, and we can give that a try instead of just going with the school and the tracks and the cohorts and all that. Okay, while you think about it, let's go and see some of the theory. So we have this, the menu today would be what is normalizing the model? What does that mean? The types of relationships, we have 3 there. We're gonna talk about extensively about 2. One of them is not as common, so we bypass it. And of course, we need to apply that using multi-table schemas. Yesterday, we saw that a foreign key is a column that we have on a table that references the primary key on another table. So through foreign keys, we can connect tables together. Togethers? No, together. So even though that's good from a developer point of view, in reality, when you talk about the design, the business domain, what you really are doing with foreign keys is you are describing the relationship between the parts of your system. So when I say that a client can come to our system and order many things, or I say a client can order more than once from our company, I am kind of talking about a relationship between the clients and orders, or between an order and the amount of items inside of that order. So that relationship is defined through the use of foreign keys. Okay, so what is this normalization thing? There's some text about normalization here, and there are quite a few normal forms. But before we know what normal forms mean, probably we need to understand what is the opposite of this. And this is not normal. No, actually is when you have anomalies in your design. And there are different types of anomalies, and this table looks awful. It's supposed to be a table. But here's some example of the anomalies. I would say read through them. But ultimately, what you want, the normal forms, they go in different levels. So what you want is a model that is at least on what is called a third normal form. What that means is that it satisfies the first normal form, the second, and then on top of that has some extra functionality, some extra properties or attributes of that model. The workflow you're gonna see is gonna give you back a model that is in the third normal form all the time. So you don't have to, you can read through them and understand the steps, and yeah, it's stable, should have a primary key, and everything should be related to, depending on the places you read about it, it could be super complicated, or they could make it sound easier, but it's interesting reading for sure, okay? So we're gonna go pragmatic here instead of concentrating on the theory, and I'm gonna show you, okay, Luis, how can I get to a normalized model or normalized enough? Let's get to it. Any ideas for what do we want to design?
I have an idea.
Please.
So I'm a virtual assistant, and I'm thinking about building a program for virtual assistants to use to help organize our clients.
Okay.
So basically, I need a list of virtual assistants, but then I also need a list of clients.
I'm gonna stop you there for a minute first.
Okay.
Hey, where's my other? Oh, here it is. So I'm gonna jump into the README. So I want to have a list of virtual assistants, right? What else?
A list of clients. And each virtual assistant can have multiple clients.
Can I say assigned?
Yeah.
I'm gonna call it VA for now.
Mhm.
Okay.
And
What
then the
else?
one other thing I thought about keeping track of is one thing we do every day is post a question for them on their page. So, like, I want to keep track of engagement questions so I can see whether or not the VA has had that particular one posted for that client, or whether the client has had that particular question posted.
Okay, so um, that part I don't quite understand. Is it so you have a pool of questions,
Mm-hmm.
and it is the responsibility of the assistant, the virtual assistant, to post one of those every day for their clients?
Yeah, so basically, I just want to be able to check if that client has had that particular question posted.
Okay. All right. This is great. This is the first time that I get someone to jump in and give me something new. All right. So let's talk about workflow, right? Because I keep talking about this workflow thing. And then we're going to apply that workflow to the process here. Remember, the goal of this, the goal of today is how can I go from, of course, we're going to clarify this a little more. I may have more questions for my client. So Barbara is going to be my client today. And so I'm gonna ask my client some questions so that I could be clear on the requirements, right, before I design that model. And data model is super important. And like, let me tell you why we're gonna take a lot of time talking about data model and asking questions and making sure that I got this, that I understand what she wants, right? And is that if you think of a house, and if you're buying a house and you look at the colors of the paint on the walls, or maybe the trims on the walls and things that you can easily, like the decoration of the house, if you look at that and don't concentrate on the structure and the layout of the house, then you might find yourself in a house that you hate later. Okay. Why? Because those things you can easily change. You can easily paint over the walls. You can easily add different trimmings. You can definitely move some things around when it comes to the decoration, maybe the lighting, things like that, right? So what's important really when buying your house or building it is the layout, the foundation, because those are things that are really, really hard to change later. When it comes to software and hardware, I make a phone that I don't like buying Teslas. I tell my daughter that I don't want to buy a Tesla because Tesla is built by software guys. Software is supposed to be malleable. It's easy to change. Hardware is not. So hardware designers, they take a long time thinking about the design and testing it to make sure that it's really, really good. We should be doing the same thing in software. Now, there are parts of their software, our software, that are easy to replace. The data model is something that is really, really hard. It's like uh, if you were from my country, the Dominican Republic, houses, since we are like right in the middle of hurricane every year, we have a hurricane season and we get hit hard sometimes. Um, Anybody that can afford it will go and use blocks and iron rods to build their houses. Like, we don't have sheetrock and you cannot punch through a wall. You need a hammer drill in order to hang a painting on the wall. Okay, is that tough? You can't really take an iron nail and just hammer into one of those walls. You're gonna lose a finger doing that. And a regular hammer and a regular drill without a hammer, it's not gonna do it either. So what I'm saying is concrete that you normally find in houses when people can afford it. So imagine if you buy a house with a really bad layout. Yeah, there is no, you can't really hammer through the walls and put some wood and put some sheetrock on it, and now you have a new layout for the house. It doesn't work that way. It's really there. It's set on concrete, literally. So your data model is just like that. Your data model is it's like the backbone of your application, and if it is wrong, everything about your application is gonna feel wrong. Everything is gonna be hard to do. Okay. So think really hard. Take extra time designing a good data. As I don't mean you're not gonna predict the future, but based on the information that you have, take extra time designing your data model. So we're gonna do that as part of this process. So let's talk about where do I start? Well, there are a few parts, right, to having a good data model. Okay, and we're gonna take probably let's do that. Let's define a couple of properties of a good data model. And this is a physical model. Remember, this is a model designed for the database schema, the physical schema of the database. What should we have in there? Well, it should capture all the data, all the information, not data, information the system needs. So when my client, Barbara, says, I want to see a list of virtual assistants, I have to make sure that the system has, that I have a place to store that list of clients, the assignments between clients and our virtual assistants, that has to be in there, right? I need to capture all the information that my client needs to see. But most importantly, if I change this, I'm gonna make this uppercase. Oh, not that, but this. We also need to capture only the information the system needs. So there's no point in me adding extra thing. Oh, maybe in the future you're gonna need this. No, I don't need it. Don't add it there until you need it. Okay. So based on the data we have now, we're gonna design the best model that we can, but don't add extra craft in there just because of I think it might be a good idea. Let the client tell you what they need and just do that. So what I'm saying is it should reflect reality, right? And if you have, and if you're on the side of you're managing the virtual assistants, that's what you see. But if you are maybe a contracting company that hires virtual assistants, the information about the virtual assistant that you as a recruiter need to keep is different from someone that employs a virtual assistant. You are capturing in software a virtual assistant, but the information, like from the point of view of someone hiring you as a developer, you're an employee. But if you're a recruiter, developers, the information you need about developers might be different. So it's got to reflect the reality of the system you're doing. Now, I said only add things that you need now, like based on the knowledge. You don't have a crystal ball. You can't think of the future. Don't do that. So what do you need? Well, you need a flexible model. So it's got to be flexible. So as you learn more, and you will learn more about the system as you go, as you learn more, this thing needs to be able to evolve. Okay. I'm going to say domain. By domain, I mean, like the domain where this is, in this case, is the virtual assistant domain. I don't know. It would be like, I don't know what the domain is. Probably healthcare, I guess. Okay. So on the beginning, we talked about Mongo and how exciting and sexy it is. And I said, no. Relational databases really are all about guarantee the integrity of your data, consistency and integrity. So it needs to do that. Because this is why we're using relational databases, right? So it needs to guarantee the data integrity. Data should be good if it's in there. We have to be able to trust it. Now, there's a trade-off for that. The better your model is when it comes to data integrity, the slower it's going to be for some things. So, I'm going to say too much because you always sacrifice performance. So there's a trade-off there, okay? And I think that it's a good place to start when you're designing your model is, okay, how am I going to use the data? And this is great because she's telling me exactly the things that she wants to see, right? She wants to see this stuff. So that means that I'm going to be querying the data to show her this stuff. Notice that she never told me, I want to save assistants. No, she said, I want to see a list of assistants. I want to be able to see a list of my clients. I want to be able to see whether, when I say keep track here, it's just like she wants to see whether, the engagement questions were shown to a particular client. So she's telling me the stuff that she needs to see. She's telling me the value of this system for me is because I have insight and visibility into these things. Okay. So a good data model is going to be, the design of it is driven by the way we access the data. Okay, the things we need to see. Are there other properties to a good data model? Yeah, but I normally just keep it here. These are the ones that I normally list. Is SQLite really scalable? For a single user, it is. Remember that the use for SQLite is not an enterprise multi-user, tons of terabytes of data. That's what servers, database servers are. But the use case for SQLite, which is in embedded applications, in iOS applications, really on your phone, how much data do you really want to store there? So it is super scalable for its use case. But as soon as you outgrow that use case, you have to move out of SQLite and move into something else. Okay. Any company that needs that level of scale would probably have a different database management system than SQLite. Okay. So what are some of the components of this? This is going to be so boring for you today. It's like so much theory and just me talking on them. It's just really boring for me too. So some of the components of this, I'm going to highlight this right here. And also I'm going to highlight this. Okay. If you are designing a RESTful API and you have endpoints to handle the client have a name in the REST ecosystem. We call them resources. So when we are designing a physical schema for a relational database, we're not going to call them resources. We're going to call them entities. So this is resources. Okay. How do we find them? They're going to be nouns. The nouns of our system normally are the entities. So a virtual assistant, a client, a question. Okay. All of those are nouns that I could see right there. Okay, excellent. A question. Those are the nouns. Those are going to be resources probably on our RESTful API, but also they're going to be entities in our database. They map really nicely to something inside of the database. Okay, so those nouns, they map to inside of the database. They map to tables most of the time. Not exactly, but most of the time. Okay. What else do you have in there? Well, we have those relationships between them. When you say multiple clients are assigned to a virtual assistant, what you're saying is a virtual assistant can have many clients, can be assigned multiple clients. So that's a relationship right there. So you need to define that. I'm going to ask you another question to clarify this relationship later, but for now, we know that there is a relationship between a client and a virtual assistant. One virtual assistant assigned multiple clients. So those are called like that, relationships. Okay. And the way that we express those inside of our model is by the use of foreign keys. Okay. Foreign keys are going to do that for us. And the last one, once you have all the entities and all the relationships, is inside of each entity, what do I care about? I'm going to ask you, okay, when you save information about the client, what do you need to see about a client? What do you need to see about a question? What do you need to see about a virtual assistant? So those are going to, they have different names. I'm going to call it properties here, but it can also be fields. It could be columns. Well, no, I'm not going to say columns, attributes. And those are going to map nicely to columns inside of a model. Okay. So given the entities, relationships, and properties being the components of a data model, now what do we do first? Well, I would say, identify the entities. Pen and paper is the best friend for that. Once you do that, then the other two, you can kind of do them together, which is identify the, so I say properties? Yeah, I'm going to say properties. The properties, and also identify the relationships. Those kind of happen kind of at the same time. But if I have to pick an order, it would probably be like this. It would be the entities, relationships, and properties. Okay. And now we're going to come to the interesting part, the mantras. I'll discover those as we work on the model. So pen and paper, right? Pen and paper. So let's get in here and create a brand new. So let's just create another one here. I say, okay, if I'm starting this and I have some nouns in here, I could definitely see if I identify the first step on the workflow is identify entities. I have virtual assistants, clients, and questions for now. So pen and paper, and I'm gonna start drawing squares. I have clients. I have virtual assistants. And I have questions. I don't know if I have anything else there, but I know that I have those three. So what is the relationship between them? There's a nomenclature to defining those things in a diagram if you wanted to. But I know that a client can have, it is assigned to a particular virtual assistant. So I know that virtual assistants can have multiple clients. So I'm going to relate those two. I'm going to tie them together here. And on the one side, I know that we have many clients. So many can be expressed with an infinite side. You can also express it with a star. There are different ways of doing this. Okay, pick one and just stick to it in your designs. This is telling me many clients to one virtual assistant. Now, on the one side, you could normally do a one. You could do a one, that's it, or a zero, that one. There's notation for that. So my question would be to you, what happens if a virtual assistant is no longer working at the company and you need to assign that client to another? Is it possible that a client through their history in your company will go through more than one virtual assistant?
Yes, it
It
is.
is, right?
Mm-hmm.
So we can no longer say that a client is assigned to a virtual assistant. We can say that at a particular point in time, a client could be assigned to a virtual assistant, but a client could have in the history more than one virtual assistant they have worked with. Is that accurate, right? Okay.
Mm-hmm.
So this is no longer one side on the virtual and many. It's actually a many to many. So I'm going to express this as I'm going to use a star here. So the relationship between the two really, and let's talk about the three different types of relationships here. So we are defining a type of relationship there. So some relationships before the mantras, three types, one-to-one, and they are easy to understand, one-to-many, and then you have many-to-many. This is not common. We're not gonna worry about it. This is it, right? This is the one that you're gonna see the most, and this is a trick, okay? So in this case, we don't have a one-to-many defined yet. So let's see what we have there. So client and virtual assistants now, that is a many-to-many relationship because for a particular client, he could have been assigned to multiple virtual assistants, and a virtual assistant is going to have multiple clients. So on both sides of that equation, we have many-to-many. Now, one thing that it's going to help you a lot is you may have a system that has a lot of requirements. Pick, again, one entity at a time until you have a few laid out, and then take relationships between two entities at once, like only two entities. And then let's look at it. What about the questions? So what is the relationship between clients and questions? There is a relationship between them, right? Between clients and questions. And the relationship is that a client can see some multiple questions, right? So you need, in some place, you need to record that a client has seen a question, right?
Yes.
Okay, so there is multiple questions. So on this side, I know there is multiple questions for a client. Now the question is, each client going to get a unique set of questions, or the same question could potentially be seen by more than one client?
It's a question pool that multiple clients will get the same questions from.
Okay, so again, on this model, I have many to many there. The same question can be seen for multiple clients, and one client can see multiple questions, multiple different questions. Yeah, for the build weeks, Postgres, it's probably because that's what we use in labs. So I would say start getting familiar with Postgres. Yeah. All right. Questions so far. You see what you have done about this process. We are defining the entities, and then we are defining the relationship between those entities. Pen and paper. Okay. So what do you do next? Well, you need to keep a list of the things, the properties that you want for each of those units. You could do that with bullet list here. I'm going to use a tool just because we have access to that. It's called dbdesigner.net. You can create an account here and then tell them that you're a student, and they will upgrade it and they give you a pro for a year. So I'm going to bring that model that we did on paper and create it here. I'm going to create a new table. I'm going to call it clients. Another table. Actually, I'm going to delete that table. And the first mantra that we'll see here is every table must have a primary key. So if that's true, then as soon as you create a table, as soon as you think of a table, you want to think of the primary key. Pick a data type, pick a name, make it consistent. I like ID. And just to start out, we're going to make this be, oh, by the way, when you create a model, let me show you this. When you create a new schema, I'm going to discard those changes. If you go to schema and create a new schema, let's give it a name here, VA. The database by default is going to be generic. So I went to schema, new schema, generic. But you could change this to be Postgres, for instance, or you could change it to be SQLite. So what that's going to do is if I pick Microsoft SQL Server, the data types available for me are going to be mapped to the data types on Microsoft SQL Server. They have a really nice selection here because those are like the main relational database management systems you'll find out there. They have MySQL, SQL Server, SQLite, Postgres, and Oracle. Those are really nice because if you have MariaDB, you can use MySQL. They use the same data types. Okay, so pretty nice. I'm gonna pick. I'm gonna assume that I'm working with Postgres. Okay, create a new schema. Now this is gonna be set up to working with Postgres. So let's go back again. Create a table. I'm gonna call it clients. Save that. And if I apply that first mantra, every table should have a primary key. I'm going to call it ID. And now I have a choice here. Look at that. That's a big choice. So data types that I could use. If you want to make it auto increment, you would probably use serial. So I'm going to make it serial. And that is going to be my auto increment. I'm going to mark it here. And this is my primary key. Cool. And this tool could even generate SQL for you for creating that stuff. But it's nice because it's going to give me now a visual representation of my tables. So if that is the case, now I know that I have every table that I create will have a primary key. I'm just going to clone this table instead of creating a new one because I get that free primary key now. And then go in here and call this. What do you want to call the table where you store virtual assistants? VAs, assistants, what?
VAs is good.
Okay. As long as everybody understand that this is not the word go in Spanish, are you going? Vas. No, it's about virtual assistant. It's great. Okay. If it's not going to be clear for everyone, make it be a long table name, virtual assistant, so that everybody knows. but I'm gonna keep it as VAs now. Save that, and now we have our table. We also know that we need that other table for, so I'm gonna clone this one and just edit this, and this is gonna be questions. Don't concentrate on the tool, it's super easy to use. Concentrate on the process that we're going through here. So now we have our three basic tables, and we have gone through the process of establishing the relationships already. And we know if we go back to all you need is this, right? We went through that process. We identify the entities. We have the relationship between those three entities so far. And we know many to many. So if I have a many to many relationship, in reality, here's what I got. Let me show you what I have. In reality, I say that this is a trick. There is a reason why I say that. In reality, when you have a many-to-many relationship, you always have a third table. And what that third table has is a one-to-many on both sides. So if I want to have that relationship between the virtual assistants and the clients, let me do it on the tool. It's easier to see on the tool. Let me show you. So if we were to write a mantra here, I'm going to tell you many-to-many third table, just like that. Always do the same thing. Okay, so I have a many-to-many, I need a third table. Another mantra is do 2 or 3 entities at a time. So for now, if I do that, I'm gonna get rid of the questions. I don't care about the questions now. They're out of my view. Oh, let me move it a little more. Now they're out of my view. There you go. I'm concentrating only on the clients and the virtual assistants. So a virtual assistant, multiple clients, many-to-many, automatic, third table. Again, I'm gonna clone it. Save time. Okay, third table in there. That's gonna define the relationship between these two entities. Now, the name of this, and here's this is not a 100% rule, but a lot of the time, what that third table represents is not a physical entity per se, but a transaction that happens in time. So the transaction that this third table is defining here is the assignment of a client to a virtual assistant. I know it doesn't look like it, but that's what it's saying. This table is recording every time I assign a client to a virtual assistant, I am going to record that transaction in this third table. So normally when you have many-to-manys, there is a third table in there that records a transaction between those two entities on the edge of that third table. So the trick comes in, actually what you have is, let's call this, you could think of it as like, is this a client for virtual assistants, or is it the list of virtual assistants for a client? How do you see it? Do you see like a list of clients for a virtual assistant, or a virtual assistant to a client?
Maybe a list of the clients that the virtual assistant has. I don't know if I understand how
Yeah.
to.
It's just that. It's like when you think about this, maybe on the stuff that you told me, I could kind of nudge the discussion in the right directions. You say multiple clients are assigned. Look at this word right here, assigned to a VA. So I think you approach this from the point of view of, I need to know the clients that a VA has assigned to it, right? So yeah, so I'm gonna go from the virtual assistant here on the left, and we could call it, unless we have other types of assignments, we could say assignments here, or client assignments or something like that, right? So I'm gonna keep it as this name, but it could also be something like VA clients, like so. What you see in this table is the list of clients for a particular VA. That's one way of looking at it. Or if you were on the other side, where what you need to do is, I want to see all the VAs for a particular client, then this would be like client VAs. But again, this represents the transaction of whenever I assign a client to a VA, I need to record it here. Okay. So one to many, right? One virtual assistant will have many assignments. This is no longer clients. This is assignments. Throughout the lifetime of a virtual assistant in your company, they're going to have a lot of assignments recorded for them for different clients. Hey, Manuel is thinking ahead. I like it. So we'll get there. So here, I'm going to have a one virtual assistant have many clients, many assignments. So the other mantra is, so this is going to be a one-to-many, one virtual assistant, many assignments. And in the case of the assignment, yes, each assignment is only for one virtual assistant because each assignment is different. It's not the same as the client. The client can have multiple virtual assistants, but when it comes to the assignment per se, that transaction is unique. Every assignment that you make is unique. It will not be repeated. So it's always a one-to-many between the virtual assistant and the client and the assignments. So how do we express this in our mantras? We said that many-to-many a third table. I'm going to say one-to-many foreign key. So the question is where? Foreign key. Where? Many side. Okay. So I need to express that one-to-many. I need a foreign key. Where does it go? On the many side. So if we look at this relationship here, is it the virtual assistant or is it the assignments that is the many side of this? Anybody can answer that. Assignments is the many side, right? We just said one virtual assistant can have many assignments. Okay. I know this is going to take a bit, okay? Because you're thinking, well, I have also multiple virtual assistants. But if you ignore everything else and you concentrate on 2 or 3 tables, right? If you go back and concentrate on these 2 and you say a virtual assistant can have many assignments on the history of it, has been assigned many times, clients. But when you look at an assignment, you say, okay, if I look at this assignment needs to tell me the virtual assistant and the client that was assigned. That's a transaction right there. They come together in that assignment. But if you look at the assignment, the same assignment can only have one virtual, unless your company could have an assignment where you say, okay, to this client, I'm going to assign multiple virtual assistants at the same time. Does that ever happen?
Well, sort of, but they all funnel through one primary VA. So like that's what I'm looking at here is the primary, like the lead.
Okay.
So I wasn't really considering the like assisting VAs.
You could consider if it's, remember that the model should reflect reality. So if that is the case, we need to go back to the model. And if we want to support that, we can support it. The simplest possible way is to have the assignment just talk about like, how do you have it on paper? If on paper what you have is you have the lead virtual assistant assigned in the assignment record, then we just record that. Let's start here because it's simpler, right? It's simpler when you only have the one. So again, on each assignment, you have only the lead virtual assistant. If there's another assignment, it's another assignment. So that's going to be a different record. So in this case, it's always going to be one-to-many. The many side is the actual VA client's side here, the assignment. So foreign key. The foreign key is going to say, I'm going to say the VA ID. I'm going to record the ID of the VA that was assigned. Okay. And since this is a serial, they have to be the same type, because remember that the way that we tie them together is because we share the same value. So if we assign the virtual assistant with ID 25, the value that we record here on the assignment is the value 25. That points to that virtual assistant, right? This builds on the stuff that we saw yesterday. So they have to be the same type. So in this case, it would be 0. Only that we're not going to auto-increment this. Okay. Now, this is a foreign key though. So I need to mark it as a foreign key. And then I'm going to say this is going to point to not the clients, but the VAs. And it's going to connect to the ID column there. And then we're going to save that. Now, this tool now shows me that arrow that says this column right here is going to reference that column over there. Pretty nice. So let's apply someone before we go, and then we're going to take a break. Someone help me apply the relationship between a client and the assignment. Tell me, what do I need and where do I add it? What does it look like?
I think you're gonna want to add a add field into VA clients as a client's ID, and then you're gonna connect that to the primary key on the client's table.
Exactly. Okay. So many-to-many relationship is a trick. It's just a table in the middle that has one-to-many on both sides. So ultimately, you're building one-to-many relationships, really. Okay. We are reflecting reality as we know it on this model. And now you have a way to see all the assignments. And you could see it in different ways. I could say, okay, for a particular client, how many VAs have been assigned to it? I could get the count of those. And if I want to know who, I could join, right? I could grab that client, join it to this table to see how many VAs were assigned. And if I want to get the VA information, I could just join it to the other table here and get the name from the VA on that side. I can also see for a VA the clients that have been assigned to them. And if I need to know that information, it's a three-way join again. I join it to this table and then to that, and I could get information about the clients. Now, one mantra that we're missing here is, before we go, and I have, yeah, I know we need to go into a break. So one mantra that we're missing here is the third table can have extra information. Okay. So I'm going to move this to be together with the third table part of it, right? So let's do this. One-to-many foreign key goes on the many side, many-to-many third table. The third table can have extra information. What information would be interesting here? Well, I would like to know when that assignment happened, right? When is this? Because you can have Barbara be a virtual assistant, and then Jason is a client and I am a client. And maybe I am assigned to Barbara. But then later, for any reason, maybe Barbara goes on vacation and I need another virtual assistant. So I get assigned to Jackie. But then when Barbara comes back, she gets her clients back from vacation, right? And then what happens is Luis this is Barbara's client that was covered temporarily by Jackie. So I get assigned again to Barbara. So you see how a client could be assigned to Barbara, then assigned to Jackie, then assigned to Barbara again, then assigned to someone else, right? And every time we need to record that. It would be interesting to see the history of that. If we need to go back and figure out, okay, in January, who had Luis? Oh, Jackie had it. So let's record that. Make it a sign on, and we're gonna make this a date. Maybe we only care about the day. We don't track that by the minute. So it's only the date. And get rid of the foreign key portion, and that's it. Save that. So now we have some extra information that you can see. We can see all of the clients for a VA organized by the date they were assigned, and you could see kind of the workload of the VA. How are they being? You can even count them for a particular period of time, and show you. Yeah, in January they have 25, in February they have 16, and March they have 28. And you could see that. You could now get that information here, but by just writing simple queries, joining those tables. It's pretty cool. Again, you haven't really thought about normalization and the rules of normalization, but now this model, it is in the third normal form by just following a simple rules. All the rules we follow is we identify the entities, we identify the relationships between them, and then we haven't really filled out any properties other than the primary key and the date, right? But that's the same process. Like, what do I want to track about each? And then the relationships, and then we say, okay, every table must have a primary key. Check, we have that. 2 or 3 entities at a time. We did that, and then one too many. We found many too many first, but eventually we had one too many. We express those with foreign keys. It goes on the many side, and then the many too many is just a third table that can have extra information, like adding the date, depending on the stuff that I need to know. And remember, in your mind, every time you add in the third table, think of what transaction am I describing. It's not always going to be that the case is that, but I find a really high percent, like 90+% of the time, what that third table describes is a relationship between the other two. It is a transaction, sorry, not a relationship, a transaction between the other two. Something that happens in time, like an order. Okay, like you have an order for clients. It's a transaction. That's what you're describing there. You describe the transaction. This is when a client ordered a particular product. So ultimately, it's not about the order, it's about when they bought something. So it's the client and the products in your company. When did a client decide to buy a product? That's the order. So it looks like it's a table. It's actually between the products and the clients, maybe 2 tables in the middle, but you have the idea of in an order where you have the client and the product. You have a product that could be bought by many clients, and then you have the client that could buy many products at the same time. So there's this many to many relationship again between the clients and the products. So the transaction is what you are actually describing there. And every case, any other system that you bring is going to go through the same process. You're going to end up with the same kind of design. Okay, so let's go take a break, and then when we come back, I'm gonna throw a challenge at you and see if we can if our mantras and our workflow hold up to that challenge. See you in 5. And we're coming back. I have a challenge. I'm going to tell you that any other line of business application that you bring, I can model. This is the simplest model that we normally have because we don't have any separate one-to-manys and stuff. But I can pretty much reuse the model that we just created, renaming some tables, and I can represent your system with it. Anybody want to take me up on that challenge? Again, this model is super simple, so we may need more objects on a new model, but the process is going to be similar to this. Oh, and by the way, we still have the questions here. Anybody wants to work with me through the questions? What is the relationship? And then Barbara could just answer any questions that we may have. Are the questions related to the virtual assistants, or are they related to the clients? Can you use databases for a game? You need to use databases for a game, for sure. I'm not a game developer, so I don't know what they use, or because it has to be very real-timey. So I can't really answer questions about that. I'm sorry. But of course they need data. They need a database because they need to remember your levels. They need to remember the items that you have on your inventory, or depending on the type of game, they need to remember your score. All of that needs to be saved in a database. Again, there are different types of games. So there are some games that are simpler. They're not real time, like an MMO or a first person shooter or anything like that. But I will delegate to other people that have done game development. Sorry. Can't know everything. So will the questions relate to both? That's a good argument. Well, can you jump in and tell us, since the VAs are asking the questions and the client are answering them. Yeah.
I was just thinking, since the VAs are asking them and the clients are answering them, yeah, then that would be related to both.
What do you think, Barbara?
I think it would only need to connect to the clients because the clients don't answer them. We basically like make a post on their social media with that question to engage their following. So like all we really need to keep track of is whether that particular client has had a particular question. Like it doesn't matter which VA scheduled it, or I don't think anything with the VA itself.
That's great. There could be another place, Ernie, and you're right, you're correct. There can be another company that decides that I really want to know whether the VA sent that question or not. But again, remember the model reflects reality. The reality for Barbara's company is that they, as long as, see what she said, I don't need to know which VA sent it or whether, I just need to know, did they get the question? Did the client get the question? So for this system, for this company, the relationship happens to be with the client. So I'm going to move the clients down here. And now I'm going to focus on those two. What would be the relationship between the two? Is it a one-to-many, one-to-one, many-to-many?
Probably one to many, right? Because there's going to be multiple questions.
Okay. So multiple questions for each client. Now, going back to my question of, will the same question be asked to multiple clients?
Yes.
Okay. So a question can be asked to multiple clients, and then a client can get more than one different question, right?
Mm-hmm.
So is it many?
Sounds like a many-to-many to me, right?
Yeah. One question, Barbara. Are these questions kind of like social media posts that you have to post like every day for engagement?
Yeah.
Oh, I see. Because questions, I was getting a bit confused. I was thinking that you were going to ask something to the client. So they're more like social media posts or content that you're putting out, right? So each one will probably be unique, right? Or not?
Yes, in the table of questions, yes.
But they actually post them to a client's account. So you can have posts of the exact same question to different clients, right?
Yes.
All right. So yeah, so it looks like a many-to-many. So I'm gonna move this table over here because a many-to-many needs what?
Third table.
A third table. I'm gonna copy this table over here, clone it, bring it down here, and say, okay, now this table though, what do we call that? What do you think about? What is the transaction that you're defining on this table?
Client questions.
Great, client questions. Okay, client questions. Now, this is not gonna be the VA ID, so I'm gonna click this little pencil here and say this is gonna be the question ID. Okay, it's gonna be serial and it's gonna be connected now to the questions instead. Okay, and then we're gonna save that. And this one is still to the clients and it's going to be connected to the clients table. So look at that. We're good to go. Now, this is not gonna be assigned on, it would be more like posted on, right? I guess, right? Is that what,
Yeah.
that makes, yeah, okay. So say posted on. And see, we are together with the client, we are discovering the names of certain things. This is you as a developer learning about the domain. You are not the domain expert. I had no idea that this happened in the world. I have no idea of this. So as Barbara explains it, she's teaching me about her domain. She is the domain expert. My job as a developer is to find the right questions and help her understand or name or think about their domain in a way that we come to a what is called a common language where we can communicate with each other on her language. So when I say post it on, I ask, yeah, that's exactly what we do. We post a question onto their timeline, or yes, we assign, a client to a virtual assistant. So I am now speaking her language, so we can communicate better. Okay, great. So Opto, thank you, Barbara. That was amazing. We just need to fill out the stuff that we want to track, but that you can definitely say, I want to have the email, the name, and all that stuff. You could do that. We did that already. So I have this model, and I challenge anyone to bring me a line of business application, this whatever your domain is, your problem is, and I am going to start reusing this same model and just renaming tables, and you're gonna get your model.
I have one.
Okay. Let's make a note.
Oh, I see the results posted, but mine is for a friend of mine that it's a DJ, and for the longest time, he has been asking me to build him a website, and I just hadn't had time around. So here I'm gonna put the specifications on the chat, and basically I think I will need 3 tables. One for the DJ account, just gonna be the owner. Just a really secure password, an email, and a phone.
Okay.
And then a customer account, just the name and an email, really. And if they want, they can provide a phone and address.
Mm-hmm.
And then another table for the events, and those need to have a status, which is so once a client creates an event, it's sent in as a requested event, and then the DJ has to approve it. And then once it's approved, they are kind of like they agreed that it's going to happen. And then once it passed, its status is changed to ended. And then I see that I forgot, but it needs a place or a location for the event.
Okay. That's great, right? It's a totally different system now. We're talking about events, locations, and all that. Totally different system. Okay,
And then
totally different system.
payments somewhere in there. I don't know where to put that, or
Yeah.
if it even goes in the database. But
Well, that's a transaction though, right? A client pays for something. So that's a transaction. So we know as soon as I see that transaction, I'm thinking that's a third table somewhere that brings together two entities. A client pays for an event. Sounds like, we're bringing two things together in a particular point in time and doing a transaction. It's free. It's like a free third table that brings two entities together. It's great. So let's model your things. We have clients. I'm gonna clone this thing, and since you're calling it customers, I'm gonna call it customers here to make it a little different. Customers. Okay, so we have that. Just clone this table over here. And then you have DJs, and the DJs are the owners, and the DJs have events, right? So let's concentrate on, let me see if I understand first the system. The system is a DJ, like a client has a party and they need a DJ. Is that what we're doing?
yeah. And there's only one DJ. There's not multiple DJs. Might not be worth it to have a separate table for that.
So what you're saying is this is a system for a single DJ. So so from the point of view of the DJ, he needs to have a list of his clients, right?
Yes.
Okay, so let's write this. Let's talk about DJs. So I'm going through the point of view of the DJ. He wants to see list of clients. And you say that he wants to see list of events?
Yeah, and be able to manage them.
What does it mean to manage events? What does it mean? What does that mean?
It mainly means just changing the status, or maybe moving the date and location around the package. Just I think it's going to be mainly the status. Just being able to move it from requested to approved, or to end it once it's done.
So we have requested, requested, approve, finish, cancel, maybe. Okay. And then location update, we understand what that is. Great. And
the other three things
is it going to keep a record of different, does he have like a different locations, or is the location just something that you add to an event?
It's just like a property. Just he needs to know where it's going to be, because the event mainly happens where the client has his party at.
Okay.
He's mobile. So
okay. So I don't know. I think this is all about clients ordering or requesting the DJ DJ offers services, and it's more of like the services of DJ offers. Is it always the same thing? It's like he just DJs for a certain number of hours, or is there anything else that he does? Is he also a clown as the second part?
He mainly is just DJ, but he has some packages because he has like special lighting and effects, and then some customers want to pay for that and some customers don't want to.
All right, so we have lighting, we have smoke, we have the music. What else do you have? Another package? You mentioned something else?
That's mainly, and then there's some people that like to have like custom made like messages on the floor or on the ceiling with special projectors, but that's all like included in like 3 different packages that he has, so they would just pick like one package from the 3.
Yeah, but here's what's going on now though. when you talk about this, and please, I hope nobody's sleeping here. When we're talking about this, I am discovering some things about the model. Like, you are taking those things and you are packaging them into something, into a package. But what is the name of those things? I don't know what the name is. I'm going to call it options, right? Manage options. You could call it services, whatever they are, right? But those are the different things that he offers. Even though you think of a package, each package is made up. He could have a package that only includes, you know, the music and the lighting, and that's it. Maybe he has a package that is like all out and includes every service that he offers. Maybe he has a package that is just music and projectors. But now you have the flexibility to maybe put a price to each one of those options or services, put a price to it. And when the client sees the app, they see all of the possible options and they say, I want this event. I want to request a new event. Here's the date. Here's the location. Here's my name. And let me see the options that I have. Oh, I want music, I want lighting, and I want the projector. I don't care about the smoke. And then the system is going to calculate that. And maybe you could have something like, well, if you buy 2 systems, I'm going to give you a 10% discount on the third one. Like, those things can now happen, but you need to record that data. So is there anything else you want to tell me besides this? Because we can start modeling this stuff like right now.
Just the events need a duration, because I think he charges per hour. So the date and location is probably good, and the date could include the start date. And then with the duration, we could probably calculate the end date, the end hour.
Yeah, that's easy. But those are properties, though. Those are not giving me new entities to think about, right? But it is important. That's that step where we say identify the properties of each of those. So you can easily do that. Duration is just a property there. Okay, so we have the list of clients and we have some events. Let's see if we can bring in our model and kind of make it work for this. All right, so we have my customers, and I could pick either of those two to make it be the events, right? It's the same thing. It's just a transaction. So maybe the post looks like an event. I'm going to just clone this because it's closer, not because it's special. I'm going to grab her down here and say, hey, this is going to be my events. And those events, I want to say that the DJ is really, really good, and he's going to have repeat clients. Maybe there's a client that comes back to him and another event for that same client. So the events are not just events for the DJ. They're going to be events requested by the clients. Definitely, right? So do you think of them as client events, or do you think of it as event clients? And now we have this question of, on a single event, can 2 clients request the same event, or no? An event is always assigned for a single client, right?
Yeah, I think they work better out as one customer might have an event, but there's no events by themselves. It's just customer events.
Okay, so I'm still going to call it events, and then we're going to come back to that because I want to make some changes to this table, right? So the first thing is the relationship between customers and events is going to be one-to-many. One customer, many events, but an event belongs to only one client. So for now, this is not going to point to client, but it's going to point, this is going to be customer ID. And then this is going to point to the customers table. Great. And we solve that side of it. So now a customer can have multiple events. There is no questions really here. But what you do have, though, for a particular event is the client bought a package. So I'm going to change this questions thing. I'm going to just clone it down here. Same thing. And I'm going to rename that to be packages. Does that make sense? I could have taken these VAs and turned it into the packages too. It's okay. I'm just took this one because it's closer. Look, it's the same. It's just connected as a many-to-many to the clients. So I'm going to take the packages here and say each event, the client picked a package. So I'm going to change this to be the package ID. Again, I'm reusing the same model, and this is going to point to the packages now. And update that. If you look at clients, client questions, and questions, look at the design. Look at the design. If you take clients, virtual assistant, and on VA clients, look at that table up top is the same table up here, solving three different problems with the exact same relationship, the same thing, three different problems. Okay, there you go. Now, there's the question of the packages, of course. The packages have services, so I'm going to take that over here, move that, keep the packages in here, because we know that a package can have multiple services that it can render, that you combine them inside of a package. So that's also going to be a one-to-many, one package, multiple services. And this, is it a one-to-many and then a service to a single package? Like, what would that be? The relationship between, and I'm just going to copy the clients again. I'm going to clone that, bring it over here, and then I'm going to call this services. What is the relationship between packages and services? Is it one-to-many, many-to-many, one-to-one? What is it?
So originally, there were only 3 packages, but if you're gonna break it down to services, then each package has multiple services, and then a service can be in multiple packages as well.
So one-to-many or many-to-many?
Many-to-many, I think.
Yeah, so third table, I'm going to clone this. I'm going to place it down here. And I'm going to say, this is actually the package services. Okay. And then this is going to connect to the package ID. And on the other side is going to be to the service ID. And it's going to connect to the services table instead. Update that. And now he has the flexibility, because this is the reality of his system. He has 3 packages, right? But those packages are a combination of different services. Maybe one of the packages has 1 service, and then the other one has 2, and then the other one has 3. But it's a combination of different services. But now he's got the flexibility of, say, pick any 2, right? Pick 2, and then combine those in a package. Now, this could have been modeled in a different way. I'm not saying that this is the only way of doing. Maybe he doesn't care about packages. Maybe he doesn't want to package services on the beginning. So if that is the case, there's another way that we can model this. We could tie the services directly to the events. So instead of having an event be connected to a package, we could say an event can have a set of services. And then this would then be event services instead. You see my point? And now he doesn't have to predefine packages. But you told me he has 3 packages. So I figured, yeah, if he has 3 packages, maybe later he adds another servers and he wants to create another package. Now he has the flexibility to do that.
The only other thing is that I don't know if I should include payments in the database at all, or maybe just manage that on the server.
No, you want to know if an event was paid. So remember that the event represents that transaction between the customer and the package. Like when they when they pick a package and they register for an event, the event, remember that you add properties to this. You can have the status, but you can also have something like paid, and then this may be true or false. But you can also have payments if you see the possibility of a client making more than 1 payment for an event, then you could have a different table for that to record all the payments. But if he always requires payment in full, no need. This is information that you can have paid on here, and then of course you want to have that be a date, and maybe a date time in this case, or maybe a timestamp in the case of like maybe And if you, I don't remember if there's, I think it's a timestamping in the case of, yeah, there's no date time here, but other systems have date time. So it's going to be a timestamp in the case of Postgres, because you want to record the time of the payment too. It's important that you record that. When it comes to payments, you want to go to the second. So you can have the paid on there. And you can have the paid amount. And you will be like, no, I don't need to record that because, I have that, the package has a price, right? So let's make this be decimal. It's going to be about money. But you could tell me, well, no, the packages have a price. So I don't really need to record what they paid. And I would argue, because the price of the package can change in the future. And when you go look at an event, you want to see how much did they pay when they paid that event, not the current price of the package. Now, if someone registered a new event and pick a package, then we bring in that price. But every time we record history data for payments and things like that, you want to save, okay, what is it that they paid on the time? Maybe you gave them a special discount. So the payment is not necessarily, not even what the price was for that package. Again, you want to record what they paid. And as you need more data and you said payments, well, now I know how much they paid and when they paid it. Is there anything else you want to record about that? Maybe their payment method? Was it credit card? Was it cash?
Yeah,
if he needs to know that, then he records that. If not, you just leave it out until he needs it.
I was wondering also to add a payment method to the client table so that he can reuse it later, or like save his credit card, but that sounds risky.
No, yeah, I was gonna say that's very, very, very risky. He probably wants to use a third-party service for the payments. Let them deal with that. I don't recommend, unless you have someone that knows a lot about security. I don't recommend. I'd rather have the inconvenience of asking the client to always provide one. If that makes sense. If clients come back and they say, this is really inconvenient, then you're like, okay, let me go get someone that knows more about security to make sure that this is always secure. So you host it on the web, on one of the main services, so that you know that it's harder to penetrate it. And then you require that customers have a really, really hard, long, and really difficult password. Like, don't do it until you're losing clients, because clients are asked to provide their information every time. Security first. But yes, it's easy. All you have to do is on the client's table, just record their payment methods. Encrypt it or something. Like, you encrypt that information in the database. If you have to, you will encrypt it with a super secret that you have, and only your server knows that secret. Again, security, but let's not get into that. All right, so here's the big reveal though. I'm gonna scroll up. Invert it. Let's do this. Look at those models. Isn't that crazy? We've done nothing different. It's the same thing. Just pick what are the things that I want to record for a particular event, transaction. Look, same thing. Same workflow, same address. We could do this all day. Any system that you throw at me, I'm just going to be cloning those tables and doing the same thing. And your system works. What can you get out of this? I could get a list of all the events. I could get a list of all the packages. Like I could have a count, say, okay, what are my most popular packages? How can I do that? I go through all the events and I count the package ID. And this is going to tell me package ID number 26 has 25 of those. And the closest one is 18. So I could see the most popular packages. I could see the most popular times of the year for events by looking at the date and grouping it by the month. And this is going to tell me I could group it by the day. I could group it by the month and day. and have an idea of throughout the year, what are the most popular times? When can I raise prices because I have more like, you see, I have more demand, I can raise the prices there and people will still buy the service. Like, I'm not telling you to do that. I'm just saying that offer and demand is a thing. What you could do is you could provide discounts on the low parts of the year so you can even out the demand. All of that information is already in there. You can get all that data out of that. Simple joins and counts, and that's it. How much money did I make last year? Aggregate by the year. You have the date. How long between the event date and when they pay? You could have that there. Like, we don't have the date of the event. Of course, you want to add that, but let's say date. Let's call it event date or something like that. And this is going to be a date, simple date. And now this is going to tell you the event happened this day. This is when they paid. Like, all of that data is in there. And of course, you have the statuses that you could just change. And you could choose to have a separate table for the statuses, or you could have just a value in there and a list of values that you control for the different states. Questions from everybody? That is the process of data modeling. It is, I need to understand the domain. I'm going to try to find the questions and I will follow the mantras. I have done nothing outside of this workflow. Nothing unique. It's just understanding, and and don't be afraid to model something and then come back as you learn more about the domain. Oh, this is not a one-to-many. This is actually a many-to-many. Add the third table in there and follow the mantras. You'll be good. Okay. And you have migrations to update your model. So super simple. Let me save this thing. That's it. Told you that was going to be boring. We do have to write some code and express some of these relationships now because we need to define a foreign key. So I need to tell you how to do that. So let's take, let's take 3-4 minutes and then come back and then define foreign keys on our migration so that you see the process for that. See you in 5. And we're back. So how can I express foreign keys in my models? Let's go back here. Look at the data folder there. And we don't have any migrations yet. Let's look at our connects file, make sure that we have, yeah, data migrations, right? So there's no migrations. So let's create a migration to represent one of those entities there. Let's pick one. Let's do that. Where's my, there is. Let's grab the first model. We have the client and the client questions and the client questions. Let's represent this line down here. Okay, they all behave the same. They're all the same thing, right? So let's take those three. Let's go create a brand new migration because I'm gonna make changes to my database, whatever that is, right? And I'm gonna say connects migrate make, and I'm gonna call it init. This is my first migration, and I can have more than one table created in my first migration. So I'm gonna create all three tables in my first migration. There you go. Now we have that new migration in there. Let's go open it. Create this, and again, we're gonna have all three tables there. So return connects that schema, create table. And this table is gonna have a name and it's gonna have a TBL object like that, right? So we're gonna create three of those. So tum, tum. So we're gonna have three create tables. So the first one is, and here's important, the order is important, right? I can't really create this table first because this table, the client questions table, is trying to connect to the client and to the questions. So the client and questions must exist before I try to create that table. So pick one of the two. I'm gonna pick, I don't know, client first. So clients, and then I'm gonna have questions. And then we're gonna have the client questions. Okay, order matters. Thank you. Line 3, schema. Hey, schema. Thank you. All right. So now there's the order, right? First the clients, then the questions, and then client questions. The only important thing is that this has to be last. And on the down, return connects. Hey, I got it now. Boom. Drop table if exists. Like that. And then we're going to do it backwards. I'm going to say client questions. And then the questions. And then the clients. Yep, the opposite order. Cool. Now that we have that, the down is complete. Let's go and expand that table there. So TBL increments. Probably do the same thing on all of them. So might as well hit enter TBL increments. Boom. Now we have the primary key solved. I'm going to forget about the other properties, but you know, you need to fill up all the other properties of the client and the questions and all that. But client questions is the one that's interesting because client questions has the foreign keys. Okay, this is the one that we care about. So how do we define foreign keys? There are a couple of ways of doing those. I'm going to pick one. Okay, and then you can pick the others. If you go look at the documentation for connects, there is a .foreign. There you go. So you can define on the table a foreign key, and then you have the rest of the stuff, right? Another thing that you could do is you can have on the column itself, you can use the references like that directly on the column. So I'm going to do that. I'm going to say TBL. Since this is doing an integer there, we need to make this an integer. So depending on the data type that you define for the primary key, the foreign keys have to be the same data type. In the case of TBL increments, it's going to do an integer that is going to be unsigned. like so, meaning it doesn't have negative numbers because it's going to start counting from 1. That means that you can have a bigger number as opposed to in the same space trying to also store negative numbers. So for TBL increments on the other side, an integer, you're always going to do integer on sign here. And the name of that is whatever name we gave it. Let's go back to the model for a minute. Question ID and client ID. I'm going to say client ID. I'll repeat. And then the client ID, I want this to be not nullable. I want you to tell me the client. So it's a good practice for your foreign keys to make it not nullable. You don't accept nulls in there. Null is a unique value, so you could potentially have a foreign key that has nullable values. So we're going to make it known. I want a client ID for the client questions. What else do we need to know about a foreign key? If you were the database asking me, okay, this is called client ID, it's unsigned and it's not nullable. How do I know that this is pointing to another table? Yeah, so I need to tell it the table that is pointing to and the column that is pointing to on that table. And the right term is not pointing, but reference. So I'm going to say it references. A couple of ways of doing this again. I'm going to show you an example of both. You could say client table.id. That's one way of doing it. But if we do the next one here, this is going to be for the question ID. Similar, but instead, I'm going to give you another option. Questions in table. Oh, it's actually references the ID. ID in table questions. Okay. Those are not complete yet, but I'm going to hit save so that we have them like that, right? Because they are easier to read. You see them in this order. So clients.id or references the ID in table questions. That's the basics of defining a foreign key. You make it be the same type of the primary key. If it is an integer through increments, you make it on sign so that you know, okay, if it's a number that is auto-incremented, I don't want negative numbers in there, don't need them. And then not nullable, if that's something you want a foreign key that cannot be empty. And then you reference it. You say, I'm going to reference this table and this column in one of those two ways. Now, foreign keys are really good. Remember that foreign key constraints will help you. If you try to save, let's go look at the data. If I try to save, oh, actually we can do this, and I think I have an I may or may not have some notes about this. Here it is. Maybe I don't. Okay, not on this one at least. Okay, so let's create some notes. Notes are important. So in the diagram here, I'm gonna say, what if I have my client's table? My pen just died. I can't do this. Ah, no, pen, don't die. Okay, my pen just died, so we're gonna do it. We're gonna take a different approach to this. Let's say sheets.google.com, and then we're gonna create a new sheet, and then we're gonna say I have my clients. I have backup. Don't worry, I have backup. So clients on this side. Where's my Zoom? Here we go. Make this like 150%. Foreign key. Do you remember what a foreign key is? Foreign key is a column on your table that is pointing to another column. An example of the foreign keys, so that we have kind of some visual reference, is those columns right here. Like we're modeling this part, right? So the question ID is a column that I have on the client questions that is pointing to the ID on the questions. It's referencing that value there. That's what a foreign key. We're good there, right? So the way that we add them in the model here is we come in here and we say, hey, First, they have to be the same type because they're holding the same value. That's the whole point of them, right? When you save on the, let's say, the client questions, you're saving the ID of the client. It's saving a value that it points to the ID of a client that exists on the client's table. So they have to be the same type. And then you say references the client's ID, or references the ID on the table questions. This is the syntax for defining them using the migrations. The concept of the foreign key is a key. It's the table has that is going to let you, and this is powerful because the database is going to check for you. And that's what the explanation that I'm going to do now is going to show you what I mean. When you're trying to save data about that transaction, the database will protect you because you have a foreign key. Look at this. And the other example is using the foreign on the table. So let's go back to here. This is going to make it a little more clear because now we're going to have some data and you're going to see why this is important. So the client have an ID and probably a name. And then on the other side over here, you have questions. And the questions have an ID and probably a text or a prompt or something. I don't know whatever the name of that is. But then in the middle, you want to relate those tables, right? So in here, you have the client questions. So remember that the client questions is a transaction that you know, okay, was this posted for that client? Was the question posted for the client? So let's keep some numbers here. Let's say 1, 2, 3. And then for the questions, again, 1, 1, 2, 3. Okay. And there is a prompt. There's a name. I'm going to make it prettier in a minute. Okay. Now, when I want to say, was this question posted? I'm going to say, I'm going to have an ID. I'm going to have a client ID. And then I have the question ID. And when it was posted on the date. Simple. So I'm recording that transaction when the question was posted for that client. So the ID is going to be, remember that this is going to be auto-generated, so don't even worry about it. It's going to be 1, 2, 3. And you want to record a transaction now. Okay. Someone posted question number 4 for the client number 1. See, the database will look at this when you try to save that data and you put a date in there. So the database is going to look at this and they're going to be like, boom, no, you can't do that, because it's going to check, because you're telling it, I posted the question from my question list. I posted a question with the ID number 4. So it's going to go and check, do I have a question with ID number 4? It does not exist. So it's going to error out and tell you, no, you can't do that. You're violating a foreign key constraint. There is no question with ID number 4. That is the reason why you want to establish foreign key constraints. It will protect you from having invalid data. Is that, do you have, anybody has questions about that? Okay, great. So that's what it looks like. That transaction, in reality, maybe you're saying, I posted number 1, and of course, that's going to go back to reset to black. Only that it didn't work. Okay, now it works. And you say, well, for the same client, then we posted number 2. And then for client number 2, we posted number 1. Then for client number 3, we posted number 1. And then for client number 2, we post, client number 3, because, you know, so whoever's working within posted number 2. And then client number 2, we finally posted number 2 for them. So you see what we are recording here is the stuff that happened throughout history. Okay, so for client number 2, we also posted question number 3. And now this table tells you, and I could run a query against this table and say, okay, are there any missing questions for client number 3? What was the last question that we posted for client number 2? Let me organize this a little better. Now let's kind of give it some borders here. Now it looks like more like a table. And I'm gonna give you an exercise. I know that we are kind of on the end of the day, but it's important. Come on. There you go. Okay, so the exercise is, I want to know, Barbara wants to know, what was the last question posted for client with ID 2? No, with the ID 3. Boom. Can you make an attempt of writing that query looking at the tables that we have there? Barbara really wants to know that, because if she can know that, when they're looking at any client, they could even automate that and say, okay, I want you to go through all my clients, find the last question that was posted, and automatically post the next question. The virtual assistant doesn't have to do that. She can actually run that process every day at a particular point in time, like a particular hour of the day. So you go through my clients, find the last question, post it, and see what the next one is and post that. No manual intervention at all. And she's like, can we do that? I saw her eyes. She was like, really? Or you could have the virtual assistant pull up their application and say, okay, post questions for my clients. And then all it's going to do is say, okay, it's going to get the list of clients for that virtual assistant that is logged into the machine, because you already have their ID, they're logged in. And then you're going to go to the client, to the VA clients, and say, grab all those clients for each client, find the last question that was posted, and post the next one. At will. Like, they could choose when they want to do that. They can do it for all their clients, or you can have an option where they look at a client and then say, pose the next question for this client automatically, without then having to go through the list and say, oh, okay, they're missing this question. No, the next one. Okay, I have one solution, possibly. Well, it says 2, but that's not what I want to know. I want the query that gives you that 2. Don't try to be slick, man. Don't try to be slick. Oh, yeah, that makes sense. I'm gonna make silence for 5 minutes so that we can think about the query. All right, I admit that was a hard one, so it was unfair. But there are some options in there. So let's look at this one. And let me think through this with you and see if they look the same once we're done. So I want to know the last question posted for the client ID 3. So select from clients where client.id equals, and I'm gonna say clients as, because I know I'm gonna be doing some joins as C right there. Say C dot ID equals 3. Okay, that's the first part because I need to filter that, right? So that's done. But then to know about the client questions though, I need to join to the client questions. So let's copy that and say join client questions as queue on C that client ID equals C that ID. That makes sense. Okay, so I'm going to use clients because I'm looking for the questions for a particular client. So I need to join. I need clients for sure, but if I'm looking for questions where the place where I record every time I assign or I post a question is on the client questions. This is the table that has that information. When I post a question, I record it there. So I need that join. So let's make this queue. Join client from quest. What is this? This clients as, oh, I'm looking at the wrong. I'm changing the wrong query. This is my query down here. So it is queue. Oh, I made a mistake there. Thank you. Very nice. So I write it down. You're correcting my queries now. Great. So now that we have that, we know that we can see all of the client questions for a particular client, and we're filtering that client. So we only see in their questions. But I want to see the last one though. So if I want to see the last one, I'm talking about dates. So I probably want to order by the, what do we call that? Forget. Call a date, post it on. Order by post, this in the questions, post it on. But I want to see the last one. So I want to see them descending so that I see the last one first. So descending. And then I only care about the one right at the top. Limit 1. Boom. Okay. See how this is a really hard query to write, but we broke it down. We started off, we started by, I know that I want the client and I filtered it. You probably didn't think that I would start there, but yeah, I only care about stuff with ID 3, so I filtered that, so get that out of the way. And then I want to know the questions for a client, so I need to go into the client questions, so I joined it to the client ID. And then I know that I needed the last one that was posted, so I need to deal with the dates. I need to figure out what the posted is, so I'm going to organize that by the posted date, but I want to see the last one at the top, so I'm going to make it descending. And then I only care about the last one, so I'm going to limit it to 1, so I'm going to grab the first one from that list. This is all going to happen at the database level super efficiently. So the client that makes this request only gets the one record that they care about. And if I only care about the ID of the question, I could just say queue that question ID. Okay, and I have another option here. If we wanted to join, you can actually continue to join down to the questions if you want to see the actual question. So we're joining here the client questions. Looks like exactly. Looks a lot like the stuff that we have out there. Only that this is not, yeah, this is getting the ID. Like we were here. So it's not confused. Not to be confusing, because they kind of look similar. I'm gonna keep one, and then questions so far. Yeah, that was a hard query. Yes, but you could see that if you have a model that accommodates any query that you throw at me, we could probably get it out of that model. Yeah, so switch it to capital letters for sure. I use the coloring for that. It looks bluish. That's it. That's it for today. Go practice, follow the mantras. I'm gonna stress that one more minute, telling you, please, 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 no matter how hard the model looks, take 2 or 3 entities at a time. Follow the workflow. Trust the mantras. Your model will work. Have a good one. See you on Slack.